So this video is on dividing monomials, and remember monomials are one item that is not separated out in between a plus or minus sign. Okay, so we are looking for bases that are the same. We are looking for exponents that we can, in dividing monomials, subtract. So the rule for dividing is to subtract the exponents. And it doesn't matter if you have a smaller number on the top, it's always the numerator subtracted by the denominator. So in this case, it would be 12 minus 5. If these were flipped around and we had 10 to the 5th over 10 to the 12th, we would still do 5 minus 12, and in this case, we would get a negative exponent. In this case, the one next to it, where we have 10 to the 12th over 10 to the 5th, we subtract those and we would get 10 to the positive 7th power. So that's what you're doing with the dividing monomials. You are going to be subtracting the exponents, and remember, they have to have the same base. So you're going to be having monomials that have many different things in them that are being multiplied together on the top and the bottom of your fractions. So for example, I believe this is number 13 on your sheet. If I have things inside, my first thing that I'm going to look for is if I can make this smaller. Because if I were to do 30 to the 5th power and 5 to the 5th power and then divide, I'm going to have huge numbers that I'm going to have to divide back down to simplest form. But if I look at this, 30 and 5 have a 5 factor in common. If I divide the top and the bottom by 5, divide 30 by 5, I get 6. Divide 5 by 5, I get 1. So I have 6 in the numerator, 1 technically in the denominator. And then here with the d's, this is the same thing as d over and then d to the 4th, d times d times d times d. Now if you look at this, anything in the numerator and the denominator that are the same when you are multiplying can be divided out. This is technically one whole. So you still have a 1 in the top and you have 3 d's in the bottom. So this is d to the 1st power, and you have 1 minus 4, which is going to get you a negative 3. The negative just means that it's in the denominator. So if I were to cancel out 1d up here and 1d down here, I have d to the 3rd power in the denominator. So right now, and I don't need this 1, it's kind of redundant to multiply something by 1, but it's going to stay there for a moment. Then all of this was raised to the 5th power. So I need to do 6 to the 5th power, and then I need to do d to the 3rd power raised to the 5th power, like we did the other day with the multiplying powers raised to powers. You're going to multiply those two together. So we have 6 to the 5th power, which we're going to use our calculator. So we put in our base, which is 6. We hit our x to the y button, and then we hit our power, which is a 5, and we get 7,776. And on the bottom, we do 3 times 5, which is 15. It's d to the 15th power. And for number 13, this would be your answer. Let's try another one. So this one here was number 11. And this one, so I always look inside. Is there anything that I can combine together already? The answer to that is no. It is already simplified. So I am going to use the power outside, which is cubed, and I'm going to cube every single item. The negative sign, the 4, the s to the 6th, the t to the 3rd, the r to the 5th. Cube it. So we have a negative 4. So if I put, and use your calculators for this. All right, so I have to put, in my calculator, I have to do 4 negative, otherwise it doesn't do it right. And then I hit my x to the y power to do my exponent, and my exponent is a 3. I'm going to cube it, and it tells me that it is negative 64. So this is in the numerator, so it stays there, negative 64. S to the 6th raised to the 3rd power. So remember to multiply these together. I really have s to the 18th power. On the bottom, I have t to the 3rd power raised to the 3rd power. So 3 times 3 is 9. So we have t to the 9th, and r to the 5th cubed is r to the 15th power. And there is nothing left over. And if you accidentally go through this and don't minimize something or simplify it, you'll see it at the end and you can just do it at the end. It's not a problem. Just that with this one, number 13, you get like 24 million when you do 30 to the 5th power. So it's a huge number that it's a lot easier just to reduce it. So this one right here is actually number 12, it looks like, on your paper. So this is one of the ones that you're supposed to be doing with the evens. So looking at this, can I reduce anything? No, they're all different bases. So it's already simplified, and I'm going to square everything. -2 times -2 is +4, and it's in the numerator. D to the 11th times D to the 11th is 11 times 2, which is 22. F to the 6th times F to the 6th is the same thing as F to the 6 times 2, which is 12. And then at the bottom, this isn't left alone because remember, you still need to do 18 times 2. And if you need to use the calculator, use the calculator for 18 times 2, 36, C to the 36th power. And looking back to make sure that there's not something you can simplify, all 4 different bases, I'm done. This is my answer to that one. So that's the top and middle portions of your sheet. The bottom portion asks you to evaluate. So I chose number 25 on your sheet. So this is what they have: z to the 4th, x squared, y, all of that divided by z x y squared. Now, I do not want to have to do all this multiplication and then have to simplify it back down. So I am going to simplify the letters first before I plug any value in. So I have a base of a z, and I have 4 minus, remember this is a 1, 4 minus 1, which is 3. And since it's positive, it's in the numerator. Anytime you get a negative, it would be, for this particular one, would be in the bottom unless it's down here already. All right, so this is the same thing as z times z times z times z over 1z, and this becomes that. So in the numerator, you have z cubed. So this one's the same thing as x times x over 1x here, or 2 minus 1, which is 1. And so if you look at it, if you cross this out, because this is one whole, you're left with an x in the numerator. And here, you're going to be left with them in the denominator. So you have y over y times y, which is what y squared is. And when you divide, remember, it's dividing by y is 1. So there's still a 1 up here, not a 0. And I have a y in the bottom. So I have now gone from this huge thing that I would have to multiply a lot by to this smaller entity that is a lot easier to deal with. So it says here that z is 10, and I need to cube that. I'm putting parentheses to show that I'm multiplying by something else. So it's not an operation inside of it, it's just telling you that you're multiplying. And then x is +2, and y is a -2. So now I need to multiply out 10 times 10 times 10, or 10 cubed. So 10, my x squared button, my exponent, and it tells me it's 1,000. So I have 1,000 times 2 divided by -2. So that's 2,000 divided by -2. And so 2,000 divided by 2 negative, and I get -1,000. So the answer to this particular one evaluated is -1,000. And that's how you evaluate.